Good morning. I hope everybody's having a great day so far, and hope you're ready to take some notes. I'm going to recap some of the stuff that we did on last time we were together. I guess that was Friday, and then we'll move into some new notes. Not going to do a lot today, but I do want to move us forward some. Typically when I do this, I'm screen recording on my computer, but this is actually on my phone. I don't know if you can see the edges of my computer monitor in front of us there. And so the screen may look funny at times, but I'm gonna do our best to help get us through this. Remember, if you have a laptop out, you should not. Actually, you shouldn't have your laptop out the entire duration of the class today. And so if I get a good report on this class, then maybe I will reconsider. But as for now, remember, we're not using laptops. So let's get into the notes and get you rocking and rolling. If you're wondering where I am in Louisville at the moment, hopefully finishing up an exam. And so I feel your pain whenever I give you a test. Know that, I'm doing something similar at times, and so I feel your pain, but that's just part of life, and we got to keep taking tests. So this is telling us a brief overview of thunderstorms at any given moment. There are nearly 2,000 thunderstorms in progress around the world. We saw several this past weekend with a lot of rain after going for a significant period without rain. The severity depends upon local conditions. Remember, you can see there in the south. Try to move my mouse. It's hard to see against the white background. There we go. In the south, because we are near body of water, and because we've got those warm air currents moving in from the southeast and north moving in from, or cold air from the northwest at times, we do tend to see more thunderstorms, mostly because we are near a warm body of water, which provides the fuel, the moisture needed for the thunderstorm. So both geography and air mass movements make thunderstorms the most common in the southeastern United States. The three things that are needed that we went over, the first thing you need is a source of moisture, which if you look back at the map in the southern U.S., there it is, we are near water, actually on multiple sides if you're in Florida. And so there is an abundant source of moisture. Secondly, there needs to be some kind of mechanism to release that moisture and heat. And so that occurs when a warm air mass is lifted into a cooler region of the atmosphere. And so you've got to have source of moisture, you've got to have air mass lifting, and then the third thing you got to have is unstable conditions. And so if the air surrounding remains cooler than the air rising up, the unstable conditions can produce clouds that grow upwards. And so this releases more latent heat. And so those clouds begin to stretch vertically, and you get an unstable atmosphere, and that sets up for a thunderstorm. Three things: source of moisture, lifted air mass, and unstable conditions. All right, limits to a thunderstorm growth. Because the rate of condensation diminishes with height, most cumulonimbus clouds are also limited in their size. And so the size of the cumulonimbus cloud is going to be what limits the severity or the strength of the thunderstorm. And really the different types as well. The first is a frontal thunderstorm. We talked about this. The weatherman always shows this. You've got the blue and the red lines that converge, showing two fronts moving into a common area. When this happens, you've got either a cold front or a warm front pushing air out. This weekend, we had a warm front moving in, which then pushed all of the cold air out. And that's why it is 80 something, I think it's supposed to be 81 or 82 degrees today. But that happens when you have a front moving in and it pushes one out. When they collide, you end up having a thunderstorm. Typically, if you've got warm air displacing cold air is when you can get thunderstorms. Usually cold pushing out warm just looks like rain. Air mass thunderstorms occur when there is an unequal heating of Earth's surface beneath one of the air mass areas. And so that's called an air mass thunderstorm. Happens over mountains and the ocean. Remember we talked about the orographic lifting up the side of the mountain. So one side you've got this lifting, and then on the far side there, as it moves over the crest, that's where a lot of the rain and thunderstorms will happen. And then the sea breeze has to do with the unheating of the surface. Remember that land and water store and release energy differently. And so during the day, the land will get really hot and the water will feel cool and refreshing. But because water has high heat capacity, the water itself is not actually changing very much. The land is doing most of the changing. And so at night, or in the evening really, you get that releasing of that heat from the ocean into the atmosphere. And so when you're sitting on the beach on your vacation or whatever at night, you can see the thunderstorm rolling in off of the ocean onto the shore. Sometimes it makes it, sometimes it doesn't make it all the way to the shore, but you can see the lightning in the distance. That is a result of this sea breeze thunderstorm. It's also why it's just not uncommon in the state of Florida for there to be thunderstorms on the beach just randomly from time to time. These things just tend to pop up, and they usually move out pretty quick as well. All right, so this is where we stopped, and so you may need to pause the video to get this down, because I know you're going to have to write, unfortunately, because you can't type, but maybe one day we'll get back to that. But if you go ahead and write this down, you can pause it, and then I will keep going. But the 3 stages, according to the direction the air is moving, is going to be what determines the thunderstorm development. So there's 3 stages. The first one is the cumulus stage. And so the air starts to rise vertically, creating updrafts. And so you can see that in this top picture. Move it over here. There we go. You can see here there is some sort of warm air mass rising vertically. All right, so that's causing a vertical stretch or displacement. During the mature stage, updrafts and downdrafts will exist side by side in the cumulonimbus cloud. And so that's the picture that's, there we go, down here. So this warm air is continuing to stretch because it is not, or the air around it is causing it to be unstable. This air is cooler, so this air is stretching up. And so now we've got these updrafts and downdrafts. So as this warm air rises, let me see, there it goes, starts to condensate, and then eventually will precipitate. And then it's the updrafts and downdrafts that form a convection cell, which produce winds associated with thunderstorms. So as these are, oh, I can't get my mouse there. There we go. As these are rising, and then you've got air coming down with the precipitation here, the rapid rise and fall of wind is what, or air is what generates wind. And so when you got warm air rising and then cooling off and then sinking down, that's going to push out wind in different directions, along with bringing some kind of precipitation. They are releasing some of the heat that was available up here. And so that's the cumulus and the mature stage. It's also during this stage that we'll talk about this in a minute. Part of this helps contribute to lightning as well. So in a thunderstorm, cool downdrafts spread in all directions when they reach the surface. And so this cools the area. There you go. This remaining surface area down here. In all directions, this cools the area where storm draws the energy from, which then causes the updrafts to cease, because all of this cooler air is forcing its way downward. So there no warm updrafts can rise, and so the cloud no longer forms. And eventually all of this energy will disperse itself out, and the atmosphere will become stable again. Remember, if you need to go back and write this down, you can always pause it All right. So with lightning, this is a transfer of electrical charge caused by rapid rushes of air in a cumulonimbus cloud. We see this, and we see this idea of lightning happening simultaneous with these stages of development. Where's the... There it is. All right, this is lining up with the stages of the cloud development. So you've got these up and down drafts, which are then going to create a difference in charge. We'll see it here. And then that sets up for this lightning strike. And eventually, once we get to this point, we won't see as much, because at this point, we're starting to cool off some. But at this point, you still got the friction from the up and down going side by side. There's a little bit up here. You'd probably see some lightning. Maybe not full strikes down, but it may be up across the sky. No lightning here as we're just lifting. And so friction between the up and down drafts removes the electrons of some of the atoms, creating positive and negative charged ions. Eventually, the differences in these charges will break down in a branched channel of partially charged air called a stepped ladder. Well, there's a typo. Should be liter, not ladder. Anyways, that stepped liter will come down here. And so this goes with what our discussion was earlier. And so as you have, where do you go? The stepped liter come down, you're going to get a reaction from the molecules and electrically charged particles near the surface, and you're going to have what's called a return stroke, which then when you combine the return stroke and the stepped liter, you then get a channel, which is the lightning strike, what you see. And so this is formed between the positive and negative regions. As that stepped liter nears the ground, a branched channel of positively charged particles rushes upward to meet it and eliminates the connecting channel with 100 million volts of electricity. So to answer your discussion question from earlier, where does lightning come from? Does it strike down? Does it come up from the ground? The answer is it does both. There is both a striking down there, and then there's a return stroke up, so it's coming both from the cloud and the ground and connecting, and then the result is the lightning that we see. And all of this corresponds, there it is, to what's happening here as the winds generate these up and down drafts in this unstable environment. This whole process here is what causes this separating of ions in the cloud, which then causes the electricity to happen. So lightning bolts heat the surrounding air to about 30,000 degrees Celsius, which is approximately 5 times hotter than the sun. That's on average there. So it's a miracle if you can get struck by lightning and live. Most people that do get struck don't. The sound of thunder that you hear is the sound of superheated air rapidly expanding and then contracting. So much like with this balloon here, you see it popping and such. That's the same kind of sound that you hear. The air surrounding it is going to expand and then contract as that balloon pops. So there's an expansion of the balloon. As it pops, it expands and then contracts back, and that's the sound. That's what makes the sound that you hear when a balloon pops. So there are many names and varieties of lightning, and people have different names and stuff that they call for it. But one of the cool facts about lightning is that each year in the U.S., lightning causes roughly around 12,000 wildfires, 300 injuries, and 58 deaths to humans. And so if you ever are curious or want to store a random fact in your head, that's probably one that you want to go with in terms of lightning. If you ever need it for trivia or whatnot, good for you. Okay, so that just about covers lightning. So our question of the day then as we continue moving forward is, where's your severe weather or tornado safe place? You need to write an answer down somewhere. I don't care. It can be in your notes. It can be on just a random sheet of paper. I don't care. But we're going to discuss this on Wednesday. This can be at your house. It can be in the dorm, wherever. But you need to know, if in the event that there is severe weather or a tornado heading for you, where would you take shelter? Otherwise, you might make our weatherman just a tad bit upset. And so he does a great job, but that's one of the things he always hounds on, is having your safe place and knowing where to go in the event that happens. I think y'all did a tornado drill 2 weeks ago with the school, so obviously we know where we're going to go in school. But where are you going to be at home when severe weather comes? Because it's not a matter of if, it's a matter of when. And especially in the South, it seems that we have an increasing number of tornadoes every year. It's like that season for tornadoes, which used to seem like it was just March, April, maybe part of May, is now really May through December, or December through May. We'll start seeing some. There was some tornadoes in Texas this past weekend, or end of last week into the weekend. There was already some in Texas. And so it seems like that season continues to grow. So you need to know how to stay safe in the event that you see severe weather. If you see here, this is a common, or I won't say common, this is a classic hook example. So if you ever see a hook shaped like this is indicating some circular rotation right in this region. And so it's not necessarily the black that you got to look at, but I would say somewhere right in this bend here, even down into here, there's going to be a pretty nasty tornado. So, but usually when you see a straight line and you see a curve coming back, that's never a good thing. So we talked about thunderstorms. Let's talk about severe thunderstorms. The increasing instability of the air in a thunderstorm intensifies the strength of a storm's updrafts and downdrafts, which make the storm severe. So I know that picture's kind of hard to see, but you can see those warm updrafts and those cool downdrafts going side by side, and that lifting cloud, here you go, that lifting anvil-shaped cloud, significant or indicative of a supercell here. So usually if you see a thunderstorm, you can see these in the clouds off in the distance. Assuming it's just a single supercell and not a large front system. This is going to be in a large front system, so you're not going to see an anvil in this. But assuming you have a clear day and off in the distance, here's an example where you can see that anvil growing, and even there's one with lightning coming out there. Pretty cool to see if you get the chance. However, don't play in thunderstorms. Severe thunderstorms can develop into self-sustaining, extremely powerful storms called supercells. And these are dangerous because these can oftentimes spin up quick tornadoes. It's sometimes not the front that you see, but sometimes, as they always worry about, it's the singular pop-ups that occur before the front ever gets to you that can produce some of the worst weather. So these furious storms can last for several hours and can have updrafts as strong as 240 kilometers or 150 miles per hour. One of the characteristics is an anvil-shaped cumulonimbus cloud, and that goes along with many severe thunderstorms. Pretty characteristic. Another characteristic is violent downdrafts that are concentrated into a local area, and they are called downburst. And so most of the time this will feel like straight line winds, but this is based on the size of the area they affect, depending on whether they're classified as a macro or micro downburst. It's determined by the size of the area that they are affecting. But these are still incredibly dangerous because they can be moving pretty quick. I mean, they can turn over mobile homes and such. And so not to be played with here, but they're not tornadoes, but they are incredibly strong winds that can leave damage behind after a thunderstorm. So this is where we're going to stop for the day. You should have a section review to do, 1 through 9. I don't know if you can read over there on the whiteboard, but make sure you do that. Number 9 involves writing a prompt for a movie. And so this is going to be a 5-sentence minimum thing. And when I say 5 sentences, I mean not repeating the same sentence 5 times. But get creative, write a scene for a movie. Don't just copy the opening scene from the movie Twister or Day After Tomorrow or whatever. Some of you haven't even seen those, but get creative, come up with a movie, or how you would like a movie to go down, and then make sure to have that 5 sentences for number 9. Do the rest of them. I'll be checking when I get back, and then at the end, when you finish that, there is a vocab matching sheet for you to do with your textbook. Definitions may not be word for word with the glossary, but I promise you, if you look in the chapter, the concept's the same, and you can be able to do that without using your laptop. So I'll check all that when I return. Remember, everything's due 11/9, all the stuff from last week and the week before, whatever. Everything's got to be turned in by 11/9 so that I can have time to start grading things before midterms are due on Friday. So if you don't get it to me, you get a 0, unfortunately, but just stay on top of it, and I will see you guys on Wednesday.